morning. I'm Devasena. In this lecture, we are going to discuss about some of the solved problems in the subject wireless communication. Let us start solving the problems. Assume the total bandwidth available is 26 MHz, where each user requires 30 kHz of frequency bandwidth for the voice communication. In this case, how many simultaneous users are possible with single antenna availability? Now, the solution for this question is available bandwidth. In this problem, they have given 26 MHz as available bandwidth. The frequency required for each user is specified as 30 kHz in this problem. Now, they have to calculate the number of simultaneous users. So, number of simultaneous users is equal to available bandwidth divided by frequency required. Here, 26 MHz divided by 30 kHz. The answer is 866 simultaneous users for this problem. Question is, draw the 60-degree and 120-degree sectoring shapes each with one example. The solution for this question is, for 60-degree cell sectoring, here is a representation. We get 6 sectors in one cell with 60 degree each. For 120 degree cell sectoring, we get 3 sectors in one cell with 120 degree each. They are the representations for this answer. Problem number 3. Find the far field distance for an antenna with the maximum dimension of 2 meter and operating frequency of 1 GHz. Solution is, the operating frequency given in this problem is equal to 1 GHz. Distance given is 2 meter. Then the lambda wavelength is equal to C by F, that is equal to 3 into 10 power 8 divided by 1 into 10 power 9, that is equal to 0.33, where C is the speed of the light, F is the frequency. Field distance is equal to D suffix F, that is equal to 2D square by lambda. Here capital D is the distance. In this problem, they have specified the distance is 2 meter. So 2 into D, 2 square divided by the lambda, we have calculated its value is 0.33. That is 2 into 2 square divided by 0.33. The answer is 26.67 meter. Problem number 4. Give the reflection coefficient if the E field is normal, that is perpendicular to the plane of incidence. Solution for this problem is, the reflection coefficient comma perpendicular is equal to capital E suffix R divided by capital E suffix I, that is equal to eta 2 sin theta I minus eta 1 sin theta t divided by eta 2 sin theta I plus eta 1 sin theta t, where eta 1 and eta 2 are intrinsic impedance of ith and rth medium. Problem number 5. The first medium is free space and the second medium has a relative permittivity value epsilon r, then what is the Brewster angle? Solution for this problem is, Brewster angle is equal to sin theta suffix b, that is equal to square root of epsilon suffix r minus 1 divided by epsilon square suffix r plus 1, that is equal to 1 divided by square root of 1 plus epsilon suffix r. This is the answer for this problem. Problem number 6. Calculate the Brewster angle for a wave that impinges on ground that has permittivity value as epsilon suffix r is equal to 3.9. Solution for this problem is, Brewster angle is equal to sin theta suffix b. Its value is square root of epsilon suffix r minus 1 divided by epsilon square r plus 1, that is equal to square root of 3.9 minus 1 divided by 3.9 the whole square plus 1. Here In this problem, they have specified about the value of epsilon suffix r, that is square root of 2.9 divided by 15.321 plus 1. If you simplify further means we get sin theta by is equal to square root of 0.204. This is the answer for this problem. Problem number 7. Give the equation for Doppler shift and small scale fading. Solution for this problem is Doppler shift frequency is denoted as small f suffix capital D, and it is given as f suffix d is equal to 1 divided by 2 pi into delta phi divided by delta t, that is equal to v by lambda into cos theta, where v is the length between 2 points along the path of the mobile, lambda is the wavelength, delta t is the time required for mobile to travel from point 1 to 2, and theta is the small angle at points 1 and 2 in the path, and delta phi is the phase angle of received signal due to difference in path lengths. Problem number 8 is draw the signal constellation and phase transitions of pi by 4 QPSK, that is quadrature phase shift K. The solution for this problem is there is a representation of signal constellation and phase transitions of pi by 4 QPSK. In the x-axis, I have to specify in phase, and in the y-axis, I have to specify quadrature. Problem number 9. Draw the signal state diagram of phase encoded pi by 4 QPSK technique. The solution for this question is, here is the representation of signal state diagram of phase encoded pi by 4 QPSK technique. In the x-axis, I have specified I channel, and in the y-axis, I have specified Q channel. I represents in phase, Q represents quadrature. Problem number 10. Find the 3 dB bandwidth for a Gaussian low-pass filter used to produce 0.25 GMSK with a channel data of capital R suffix B is equal to 300 kbps. Solution for this problem is given the Gaussian LPF produces 0.25 GMSK and the data rate value is capital R suffix B is equal to 300 kbps, and capital T is equal to 1 divided by capital R suffix B, that is equal to 1 divided by 300 into 10 power 3, that is equal to 3.3 into 10 power minus 6 microseconds. B into T is equal to 0.25. So B is equal to 0.25 divided by capital T, that is equal to 0.25 divided by 3.3 into 10 power minus 6, that is bandwidth B is equal to 75 kilohertz. This is the answer for this problem. Question number 11. Draw the basic linear transversal equalizer structure. Here is a representation of basic linear transversal equalizer structure. Question number 12. Draw the code word for block code. Here is a representation of code word for a block code. Question number 13. Draw a diagram of two clusters from a cellular concept. The answer for this question is, here is a representation of two clusters, cluster N1 and cluster N2. N1 and N2 having 7 cell pattern is represented here. Thank you very much for listening this lecture. If you like this lecture means, kindly share this video to your friends. For further updates, kindly subscribe my channel. Thank you.